Okay, we're still in 2.5 of Barnett, exponential functions, and our next goal is to be able to identify the properties of base e exponential functions, so we'll look at those next. So remember, exponential functions so far we've written as f of x equals b to the x for some base b. This number b is called the base. Well, of all the possible bases b we can use, probably the most useful is the exponential function with base e. E is the irrational number, and like pi, cannot be represented exactly by any finite decimal fraction, right? That's why it's irrational. However, it turns out that e can be expressed as closely as we like by evaluating this expression here. 1 plus 1 over x, the quantity raised to the power of x. In fact, if you take a look at this table here, you will see that it illustrates what happens to this expression as x gets increasingly larger, right, as we up the value of x. So notice if x is 1, we simply get 2, right? Replace x with 1 here. When x is 10, we get this value. And then we have x equaling to 100, 1,000, 10,000, and then 1 million here. So notice the bigger x is, the values for this expression, 1 plus 1 over x raised to the x power, approach a number whose approximation is about 2.718. 2.718. In fact, the bigger and bigger this gets, the closer and closer the approximation is to the number e. That's how we define this number, e. And if you look at the exponential function with base e, here it is graphed as well as y equals e to the negative x. Once again, I hope you notice the two are reflections of each other. The y-axis serves as a mirror, and those are two mirror images, reflected over the y-axis. Y equals e to the x increases pretty rapidly, as you could tell, just like all the other exponential functions we've seen. E to the negative x, the black curve here, always decreases. Both of them have 0 as the horizontal asymptote, just as expected. The domain for both is negative infinity to positive infinity, and the range is 0 to infinity. So that's exponential functions with base e. So we're going to use those for some application problems, and relative growth rates is one concept that follows next.